Energy changes. This is Unit C2, Section 5, called Exothermic and Endothermic Reactions on the specification. You need to be able to say what exo and endothermic reactions are, describe patterns and results given to you, explain what a reversible reaction is, and to know a few examples of exo and endothermic reactions. Whenever a chemical reaction occurs, there'll be a change in the amount of energy the chemicals have, and so energy will be transferred to or from the surroundings. Exothermic reactions are reactions that give out energy as heat, making things hotter. Exo is like exit. Energy is exiting the chemicals as heat. If the chemicals take in energy, this is called an endothermic reaction. These reactions make things colder. In an exothermic reaction, we normally say the surroundings get hotter. This is true, but don't imagine that this means the chemicals get colder. Everything gets hotter in a fire. There isn't a bit in a fire that gets colder. Stored chemical energy is turned into heat energy in an exothermic reaction, and this energy is released. In an endothermic reaction, heat energy is taken in from the surroundings and turned into stored chemical energy, which you aren't able to feel. Describing patterns and results is something that appears in exam questions in a few areas. Energy changes can be a good area to set them in. If you get a question on this, then they will give you a table of results or a graph to use. A table of results seems more likely, and we looked at graphs and rates of reaction, so a table is what we'll look at here. Do check you understand what is happening in the experiment. In this case, a solid is added to some water and the temperature change is measured. Examiners often say that students look at the wrong parts of the data, for example describing the trend in the starting temperature, so watch out. Think about what is being changed. The mass of the solid added, and what it's affecting. The temperature change, not the start temperature. The final temperature will be affected by the mass of the solid added, but also the starting temperature. If the temperature is higher at the start, then the final temperature will be higher too. As I've said before, if you're asked to describe the pattern, don't try to explain it. Explaining why the temperature changes is covered in Unit C3. Here, as the mass of solid added increases, there is a larger drop in the temperature. After 16 grams, the drop in temperature starts to level off, and adding more than 20 grams has no further effect on the temperature drop. Make sure you can describe changes like this in the GCSE exam. Reversible reactions are covered in more detail in Unit C3. You do need to know a little about them in this module, however. In a reversible reaction, the starting chemicals, that's the reactants, can react to form the products, but the products can react to form the reactants again. You came across the thermal decomposition of limestone in the C1 unit. Make sure you know the reversible reaction sign, as this can be an easy mark in a GCSE exam. The energy change for the backwards reaction is exactly the opposite of the forwards reaction. Here, the forward reaction takes in nearly 18 kilojoules of energy if you heat 10 grams of calcium carbonate, so the backwards reaction will give out nearly 18 kilojoules of energy if you make 10 grams of calcium carbonate. The specification mentions a few examples of exo and endothermic changes. Thermal decomposition reactions are endothermic, and dissolving some solids is an endothermic change. Remember, dissolving isn't really a chemical reaction, but it is endothermic. You may well have seen a sports injury pack, the ones that need you to burst a little bag inside a much bigger bag for them to get cold. They often contain potassium nitrate, which dissolves in the water when you burst the small bag of water. Exothermic reactions are much more common. Hopefully you will have noticed that burning releases heat energy. Oxidation reactions are exothermic, and burning is in fact an example of an uncontrolled oxidation reaction. In Unit C1 you also came across the reaction between calcium oxide and water. This is used in self-heating cans of coffee and food for camping and walking trips. That's it for exothermic and endothermic reactions. Next it's on to acids, bases and salts.